Hi everyone. In this video, what I want to do is talk to you about two functions, which are our first trigonometric functions, and they are written right over here. So it's the sine function and the cosine function. So these are the two stars of this video. You may have seen these before, but really what I want you to get out of this is understanding what these functions are, what are their inputs, and what are their outputs. So you see in front of me, I have our worksheet Radians Visually, and so we used this worksheet in the past to talk about radians and degrees and what those meant. And so what we found out was a radian tells us about some distance traveled around the unit circle. So if I start at this point 1, 0, and I travel a distance of pi over 4 along the unit circle, the ending point where I'll be is right here. Right? So I'll be standing on this point right here, 0.707, 0.707. And if I traveled a little bit further, say if I went over here to 7 pi over 12, if I traveled that distance, these would be the coordinates of my points, right? I would be standing on this point, and I would be here at negative 0.259, and my y-coordinate would be 0.966. Okay. So the question we have is, if I travel some distance around the unit circle without actually having this worksheet in front of me, is there a convenient way for me to figure out what the coordinates of my point are? So say if I traveled 2 pi over 3 around the unit circle, what would my x-coordinate be, and what would my y-coordinate be? And so this is where our two functions sine and cosine come in. So the distance that I said to travel was this, 2 pi over 3. And what I'm going to show you is the x-coordinate. So when I walk from this point right here, so I'm going to start here at 1, 0, and I'm going to walk along the unit circle a distance of 2 pi over 3, and then I'm going to stop. And my prediction is that the x-coordinate of that point is going to be negative 0.5, and the y-coordinate of that point is going to be 0.866. And so this is how we define these two functions, sine and cosine. The cosine function takes an input, which is a distance around the unit circle, or an angle, and the output that it gives you is the x-coordinate of that point on the unit circle. And the sine function does the same thing. It takes in an angle, or a distance around the unit circle, and it gives you the y-coordinate of your ending point. All right, so let's go ahead and let's walk along the unit circle until we get to 2 pi over 3, which is right here. And so again, we should see the x-coordinate is negative 0.5, and the y-coordinate is 0.866. And so that is exactly what we see. So if I plug in any of these points, any distances, what we should see is that the cosine function will tell us our x-coordinate, and the sine function will tell us our y-coordinate. All right, so what we see here is some of these values really aren't so nice. And so what this is since we're using Desmos, which has a calculator in the background, it's giving us these decimal numbers. So what I want to do is just show you a couple of these numbers, and I'm going to give you their exact values. So again, if I come over here to pi over 6, we see this number 0.866 come up and 0.5 come up. And if I go here, we see this number 0.707. And if I come up a little bit more, we see 0.866 again. Okay, so 0.866 and this 0.707 are going to come up a lot. And for our reference, here are what the exact values are. So when you see this 0.866, what Desmos is doing is it's giving you the decimal representation of square root of 3 divided by 2. And when you see 0.707, Desmos is giving you the decimal representation for the square root of 2 divided by 2. Okay, so we could talk about where these numbers come from or why do we get them. Maybe we'll do that in a future video. Okay. So as you're moving around the unit circle, we've seen that we keep getting some of the same values over and over again. So here we see 0.707, 0.707, and if I come up here to pi over 3, I have 0.5, 0.866. So it seems like I've seen these numbers here before. In fact, if I kind of went straight across my circle and looked at the point over here, that was 2 pi over 3 that we saw earlier, it looks like it has pretty much the same coordinates except this one is negative. And what if I went straight down? Right, so let's go all the way down to the bottom, down here, and see, that one looks like it has the same coordinates too, except they're both negative. And then if I went straight across over here, right about here, well, I have the same coordinates except now my y-coordinate is negative. So this is one of the interesting properties about the circle. It has these nice symmetries. And so if I knew the coordinates of this point, and I knew how these other 4 points were related to it, I should be able to figure out those values too. Right, and so this angle right here, in fact, all these angles in the first quadrant are what we call reference angles. Right? And so the reference angles that we typically use for learning, so the angles that I like to talk about as learning angles, are these 5 angles here. So 0 is one of our learning angles. Pi over 6 is one of our learning angles. So we're going to want to know these coordinates. Pi over 4 is one of our learning angles. Pi over 3 is one of our learning angles. And then the last one is pi over 2. So sometimes if you're reading in other books, they call these special angles or reference angles. And so the topic of our next video is going to be how can I use my knowledge of the first quadrant to figure out the values of sine and cosine, or the x and y coordinates of various points on the unit circle, just through some symmetries and knowing what quadrants they're in. So I'll see you then.